So in this video, we're gonna look at different kind of the function of the statistics. And I start by here the data source you'll be able to see on your slides. And I want you to read the textbook. Like I said, there is nothing more I should explain for that because it's basically two different kind of data you can collect it. The first way is you go out to collect your own data. You design a survey and send out to the survey respondent and collect the data. And so another way to collect the data is go using another source called a secondary source. So you basically go to the website, government website, or from other scholars, paper published using the data that other people already collected to do your statistic or business analysis. So that is called secondary data source. The reason I recommend you to read the textbook is because um, you have the project for this class. So one of the important tasks is to get the data. So look at the textbook and they show you several interesting websites and where the data usually published, especially the government website. And go log in, try to click those links to log in those data set, website to look for the data, to look at it and see if any of the data source can inspire your idea of the project. And so that will be very, very beneficial. Therefore, this part, I will just let you go through it, and there is nothing more to explain. So make sure read textbook and visit those websites to find the data source that might inspire your idea of your project for this class. So generally speaking, the statistic can be used for two ways. First, use the statistic to describe the facts. So use the statistic to describe the business situation. And so most of the statistical inference in the newspaper, magazine, company reports, and other publication consists of data that are summarized and presented in the form that is easy to understand. So, for instance, we are experiencing the COVID-19, right? And and also we have so many other pandemic too, and the medical healthcare people collecting data like who is more likely to getting the virus, who is more likely to get a severe symptoms, so who is very likely. So that's a probability, right? So those numbers are calculated by collecting data, use the statistic method to calculate the probability who is more likely. So that probability is considered as a descriptive statistic. And here, I want to give you a broad summary about what will be the potential method you can use the statistics to summarize the fact. And in chapter 2 and 3, we're actually going to spend more time on those methods. So therefore, you will see different kind of method in the next few slides. Don't worry about that, oh, I don't know how to generate it, because we're actually going to learn how to generate the chart and the table and the numbers in chapter 2 and chapter 3. So generally speaking, we can use tabular, graphical, or numeric to summarize the data. And so the tabular is a professional way professional way to call table. So basically, you can use a table, graph, and a number to summarize your data. So they are all considered as a descriptive statistic. So which means the statistic doesn't have to be a number. It can be a chart and a table. So first, I will show you an example that can be considered as a tabular method, and I'm going to show you an example considered as a graphical method, and then show you the example as a numeric method. As I said, chapter 2, we're going to focus on the tabular and the graphical method. And in chapter 3, we're going to focus on numeric method. So let's look at the tabular method. So this example is about Houston Auto Repair. So the manager of the Houston Auto would like to have a better understanding of the cost of the parts used in the engine tune-ups performed in her shop. She examined 50 customer invoice for tune-ups. The cost of the parts round to the nearest dollar are listed on the next slide, which means you're gonna see 50 observation in next slides. So without any statistic method, when you look at this data, it's just a bunch of numbers. This is a bunch of numbers. You won't be able to get any business insight. Don't tell me, oh, I see the cheapest one is 52. The most expensive one is 109. No, you are actually using the statistic. The minimum value and the maximum value, they are all statistics. So you don't use many of those methods. Don't tell me the range. Don't tell me minimum value, maximum value. you won't get any business insight, right? So therefore, we're going to ask the statistic to help us. First, I will show you is considered as the tabular method. Like I said, tabular method is a table. So therefore, the table we're going to use here is called a frequency and the percent frequency distribution. And we're going to learn more detail in chapter 2 in terms of how to generate this table using Excel. And so this is the tabular method. If I'm talking about the graphical methods, this is the method I use. This is called a histogram. So this is a graphical method to summarize the data. Again, we're going to learn this method from chapter 2 using Excel to generate this histogram. And the third method is called a numeric method. So if we try to use a numeric method to summarize this 50 observation, and you can use the average or mean. So you can use the Excel to calculate the average. So you know the average is $79. So these are three possible methods you can use to summarize this 50 tune-up cost. Obviously, you will be able to get more insight, much more insight by just looking at the 50 raw data. So you will know average. You can look at frequency to get your business insight. So this is these three methods we are using to summarize the data to show the business insight. So this is one function called a discrete statistic. We also can use statistics to predict. So in those situations, we call it statistical inference. And how it works. And to understand the statistical inference, we have to identify this very important component. First, population. Second, sample. So population is the set of all the elements of interest in the particular study. So for instance, in the earlier video, I talked about if you try to, most of you guys, many college students want to get a good GPA. Obviously, everybody care how I gonna improve my GPA. So what will affect the GPA? In order to carry on that study, if you think about the population, though that's gonna be all college students all over the world. So that's so many, right? You won't be able to get all the information from that. What are you gonna do? You're gonna sample. So therefore, sample is a subset of the population. And keep in mind, since the sample is a subset of the population, it has to be able to represent the population. For instance, as I mentioned, you want to see what can affect the GPA of college students. So your subsample has to be able to representing all the college students all over the world, right? So that will be the subsample. Then you're going to say, I cannot do it. So what are you going to do? So then you're going to redefine your study topic. Maybe you only want to know what going to affect the GPA of Edinburgh students GPA. If in that case, your subsample is easier to identify, and you go to different majors, survey 5, 10 students, and then combine all the data together. You got your subsample, right? So your sample has to be able to represent your population. And then the method we're using to collect info, sometimes we can very directly identify the population. So the method we're using called a sensor. So every 10 years, U.S. will conduct a sensor. So literally survey everybody in the population about their characteristics. So that is the method they use to directly identify population. However, if you don't have that luxury, the money, the time, the power, you're gonna just focus on your sample. So how you're gonna get the value for your sample data, and you're using the sample survey. So that's how these four concepts connected. So the sensor is the method you use to know population directly, and the sample survey is the method you use to understand the sample. And how about the statistical inference? So think about the population has so many characteristics. If you think about even about the sensor, the government doesn't ask every detailed question. They have the question they're interested in, like your household income, how many people in your family, etc. They don't care about any other things, right? So they have something they're specifically interested in to know. So those are the characteristics. So the population is we use a parameter to characterize the population in order to know the parameters value while using the sensor. And so equivalently, and to understand the sample, we don't want to know everything about sample, and we only want to know certain characteristics. So what kind of characteristic we want to know? We are using the statistical inference to representing or to characterizing the sample. In another way, So the parameter is used to characterize the population, and the statistical inference is used to characterize the sample. So there is one more step we need to do. So the ultimate interest we have is about population. We use sample is like a detour because population is too expensive to understand. Therefore, we go to the sample. So at the end, we are estimating my statistics, statistical inference. Our ultimate goal is try to prove if my statistical inference can be used to representing the parameter because the parameter is used to characterize the population. If that's the case, and then all the information we obtain from the sample can be used to predict the population. So that's the rationale. Let me use a graph to help you understand how this works. So ideally, we want to know the population. However, it's very time consuming and it relies on a huge power like a government. And so usually we cannot do it. Therefore, we turn to use a sample. We turn to use the sample, and after we collect the sample using the sampling survey method, and we'll be able to calculate a statistical inference. Statistical inference, like here, we are using average. And then if we can prove that average can be used to characterize can approximately equal to the parameters, which is the population average. If I can prove this connection, and then whatever we estimate based on the sample can be used to representing the population, and then we can use this number to forecasting the population. So that's the rationale of statistical inference. So you can see for statistic, we have two different functions. One is you literally use statistics to describe the fact we're using. Another is we can use statistic to guessing what's happening in population. If we can prove the sample information can be used to representing the population, and then we literally can use the statistic to forecasting what's happening in the population. So this is always happening. So this method was used by the marketing firm. So when they are trying to understand if, for instance, Walmart try to add in more variety of the organic food, obviously their ultimate goal is try to improving their sales. So if by adding more organic variety won't help them to increasing their sales, why bother to do it, right? So instead of adding the organic product in all the Walmart shop, they usually chose certain location, try to adding experiment, adding more organic variety, and to see by doing that how will that affecting the revenue for those stores. So those are considered as a testing store. So what they are doing is they are creating this sample, those experimental stores based on the data they collect from the experimental store to understand whether the action they are taking going to really impact the business. If that's the case, and they forecast, okay, that's going to work pretty cool for all stores, then they will make sure all store across the all over the world going to implement the same method, same strategy. So this is called a statistical inference. And in our next video, what we're gonna look at will be uh, before we end in this video, and I still want you to look at a practice question and try to help you understand the differences between discrete statistic and inferential statistic. So look at these two examples. Both of them are using statistics. What I want to ask you, which example is for inferential statistic and which example is for the discrete statistics? So question example A, the Alcohol, Tobacco, and Firearm Department reported that Houston had 1,791 arrested gun dealers in 1997. So obviously you can see a number, instantly identify a number that 1,791 arrested gun, right? And look at the second example. Based on the survey of 400 magazine readers, the magazine report that 45% of the reader prefer double column articles. So the statistic in second example is 45%. So now I want to ask you, which one is inferential statistic and which one is descriptive statistics? Yes, the first one is descriptive. The second one is inferential. So actually, for me, I want to offer you a tip. So sometimes it's very easy to identify inferential statistic. If it's not inferential statistic, it has to be descriptive statistics. So when I try to identify the inferential statistic, that is after reading the case, I try to ask myself, can I identify my sample and population? If the case is yes, and then that will be an inferential statistic. If the answer is no, then you are very likely looking at discrete statistic. So look at question B first. Like I said, B is an inferential statistic. Why? Like I said, first, see if you can identify the population sample. Based on the survey of 400 magazine readers. So my question here is, do you think this magazine only have 400 readers? Of course not. It should be at least 400 magazine reader, right? Look at their conclusion. The magazine report that 45 of its reader. So based on this 400 surveyed reader, they got a number which is 45% to conclude. The conclusion is about all readers. Obviously, you can very quickly identify the sample and the population. Sample is 400 magazine reader and population is all magazine readers. So that's why this 45% is an inferential statistic. Now go back to look at example A. We will be able to find population or sample, or that basically just stating the facts. Of course, it's basically just stating the facts. Look, they said that in 1997, the Tobacco Arm Department reported that Houston had 1,791 registered gun dealers. So that's the fact. There was no sample, no population. However, if they change the question to as based on 1997 data, 20% the people holding have registered gun dealer. Therefore, 2007 also have 20% people own the gun. So in that case, that will become an inferential statistic because you can see the population and the sample. The sample is the 1997. The population is across the whole time horizontal and how many people owning the gun. So again, if you can identify a sample in the population, that will be a inferential statistics. If you cannot identify sample in the population, it's basically just stating the facts. That will be a discrete statistics. So in our next video, and I will talk about how the statistic might be lying and also what is the ethical guideline. So which actually is very important if you decide to choose business analytics or data science as your career path, you have to holding a higher moral standard.